Hey guys, welcome to eMath. Today I'm going to do a Cambridge A-Level math paper from October-November 2020, and I think it's one of the latest paper, right? So I'm going to do paper 1, which is pure math 1. I think it consists of 12 questions, alright, on pure math. And the time allocated is 1 hour and 15 minutes. I hope I can finish on time, okay? So before I start, a few disclaimer. First of all, I am not an A-level student or a tutor or marker, and in fact, I never take A-level in my life. Okay, so I don't know how the marking scheme will look like. I don't know where is the points, where is the marks. So what I will do in this video is I will try my best to write out all the steps, make sure it is clear enough, and to make sure that you can understand. Right? So hopefully you can understand. And second of all, there are some topics in this paper which I'm not really familiar with. So because actually I skipped my year 12, alright? So there are some topics that I'm not really familiar with. So please forgive me if I make any mistake or if I explain anything wrongly, right? And third of all, good luck to all the A-level students. Okay? So without further ado, let's start. Okay, first question. Find the set of value of m which the line, okay, you have a straight line equation and a parabola, right, and a quadratic equation. So when you see the question, it says do not meet, means there is no there is no real solution, which means the graph, the curve and the line will not intersect. So what you can do is, okay, so you let this be equation 1, let this be equation 2, equation 1 sub into equation 2, so you have 2x squared plus 5 equals to mx minus 3. So you just write it in into a standard form of quadratic equation, and you use the determinant, which is b squared minus 4ac. And because the question says no real solution, means your b squared minus 4ac should be smaller than 0. Okay, then you can find the range of m. Okay, so now I will just go ahead and rearrange this. It will be 2x squared minus mx, then 5 plus 3 is 8, okay, equals to 0. So now my a is 2, b is negative m, and c is 8. I will now put my b squared minus 4ac to be smaller than 0, negative m squared minus 4 to 8 smaller than 0. This is m squared minus 4 times 2 is 8, 8 times 8 is 64, is smaller than 0. So obviously, okay, this can be written as m plus 8, n minus 8 smaller than 0. Then you can draw the sign diagram, or you can roughly sketch a graph like what you did in your SPM. Okay, it's up to you. So for now, I will just do the SPM way, which I will sketch a graph. Okay, we have negative 8 and 8 here. And because your m is positive, right? So it will be a smiling parabola. And the region that we want is smaller than 0, okay, which is this part. So your m will be in between. Okay, your m is in between 8 and negative 8. And that's it. And the question wants you to find the set of value of n. So you may write it in interval form. And in this case, it is not inclusive of negative 8 and 8, right? So use round bracket negative 8, comma 8. Yeah, and that's it. Okay, question number 2. Okay, the equation of a curve such that your dy dx is that one. It is given that the curve passes through the point 2, 7. Okay, so because you are actually given the gradient function, in order to get back the equation of the line or the curve, actually it's the curve, you need to do the anti-derivative, which is integrate. Okay, I'll just write here, our direction is step 1, we find the anti-derivatives, which is you integrate. And after you integrate, you will have a plus c, right? So in order to find the c, you will just sub in the coordinates given. Okay, so our step 2 is to find the constant c. then we write it together again. So for this equation given here, I'm going to write it here, dy dx equals to 1 over x minus 3 square plus x. Okay, now I'm going to integrate both sides with respect to x. Okay, integrate with respect to x. So this dx and dx will just cancel off. So we have integral of dy. Okay, just integral of dy. Integral of dy is actually integral of 1 dy. So it's actually y. Okay, and I think to make our life easier to integrate, okay, I will just write this as like this, -2 plus x dx. Okay, and okay, then we can directly integrate. We don't have to do any use sub or use any integration technique. Okay, so now perform the integration. Power plus 1 divided by new power, then multiply with the derivatives of the bracket inside, okay, which is 1 plus this x squared over 2 plus c. So write again, negative x minus 3 negative 1 plus x squared over 2 plus c. Okay, so this is our equation. And now you want to find the value of c. So in order to do that, you will say, okay, the point given is 2, 7. At 2, 7, okay, your y is equals to 7. Your x is 2, negative 1 plus 2 squared over 2 plus c. Okay, then you just solve for your c. And in this case, 2 minus 3 is negative 1. Negative, negative become positive. The whole thing here is positive 1. So bring the, and 2 squared over 2 is 4 over 2, which is 2. So 1 plus 2 is 3. You bring the 3 over, it will be 7 minus 3, which is 4. So your c is equals to 4. And with that, we can write out our equation, because the question 1 equation, find the equation of the curve, right? So we just write y equals to negative 1 over x minus 3 plus x squared over 2 plus 4. And that's it. Alright? Then question number 3. Okay, A being pumped into a balloon in the shape of a sphere. Okay, a sphere before, okay, sphere, and its volume increasing at a constant rate of 50 cm3 per second. Okay, find the rate at which the radius increase when r is equals to 10. So first of all, the volume of a sphere is equals to 4 over 3 pi r cubed. Okay, then constant rate, what is this? This is actually dv dt, right? It's a rate of change question. Okay, then find the rate at which, what do we want? We want to find the rate of change of radius, which is dr dt when your r equals to 10. Okay, it's given here. So obviously when we have like a rate of change question, we know that we need to use the chain rule. And our goal is to find dr dt. Let me just write here, dr dt. How do we get that? Is dr dv times dv dt. And we already got one of them, which is here, dv dt already got. And now we just need to find dr dv, alright, dr dv. We can get it from this formula here. Okay, so volume equals to 4 over 3 pi r cubed. So dv dr equals to 4 over 3 times 3 pi r square, which is 4 pi r squared. But this is dv dr. We need dr dv. Maybe my handwriting is not so good here. Okay, this is a dr dv. We need dr dv. So what should we do? Just take the reciprocal of it. So dr dv is just 1 over 4 pi r squared. Right? So it will just be 1 over 4 pi r squared times dv dt, which is 50. Okay, and we know that we want to find dr dt when your r equals to 10. We just sub in our r. Okay, 1 over 4 pi 10 squared times 50. Okay, 10 squared is 100. Sorry, 10 squared is 100. 50 over 100 is 1 over 2. 2 times 4 is 8, so the answer is 1 over 8 pi. Okay, that's it. Okay, question number 4. Okay, it's a trig function. And it's about the shifting and scaling of the graph. So I think the question is very nice already because it already gives you the graph of y equals to cos theta. You just have to do the stretching, compress and shift up, shift down. Okay. There are 3 marks here, but I'm not sure in A level whether you need to write it step by step or not. So I will just write step by step. So from the first graph, which is the original graph, y equals to cos theta. What is the first thing that I will do here? Because the first thing you notice is the period become half, right? So originally you have 1, 2 cycle. Is it? Yeah. From 0 to 4 pi you have 2 cycle, and now you only have 1 cycle from 0 to 4 pi. So which means the graph is actually stretched horizontally by a factor of 2. Okay, I'll just write using blue pen maybe. So after you stretch horizontally by factor 2, horizontal stretching means it is y equals to cos half theta. So now the graph will look like something like this. Here, yeah. Okay, you stretch the graph. Then next, actually the order doesn't matter, but I just write whatever that I can see here. The next step I will do is maybe I will stretch horizontally, because you see the amplitude here. The amplitude here is actually 2, right? But the original amplitude is only 1, so I need to stretch it, make it become taller, right? So what I will do, okay, let me write it down first. I stretch vertically by factor 2. And what do we do when we stretch vertically? It's actually, in theory, it's actually half y equals to cos half theta, right? And if you bring the half over, it will just be y equals to 2 cos half theta. Okay, so now the graph will look like, okay, maybe I use green color. Well, I think it will start from 2 here, then to -2, something like this. Yep, it become taller. And last step, just shift it up. Shift, okay, let me use this one. Shift how many units up? Shift, okay. So from here you see 1, 2, 3. You actually shift 3 units up. Okay, shift up 3 units. So what you do is y equals to 2 cos half theta, the whole graph, plus 3. And that's it. That's the equation of the upper curve. Alright? So if you know the properties of a trigonometric function graph, which is actually right here, y equals to a f. This f can be sine, cos, tangent, secant, cosecant, whatever, of bx plus c plus d. Okay, if you know what each and every one of them do, then you can actually directly solve it. Okay, so I will just go through very quickly. Your A actually in charge of your vertical stretch or vertical compress. Okay, then B in charge of horizontal stretch or horizontal compress. Right. Then your C is actually shifting left right. Okay, left this right left. Then your D is in charge of shifting up down. Okay, so you can actually see from here, because it is stretched horizontally, which means it is your B is equal to half. Okay, your B is half, and it is stretched vertically, so your A is equals to 2. And what else? It is shifted up 3 units. So your D is equals to 3, and your C is still 0 because you don't shift left or right. So from here you can actually directly see the answer. It's actually this. Okay. 5. In the expansion of 2x squared plus L over x to the 6, the coefficient of x to the 6 and x to the third power are equal. Okay, this is a binomial expansion question, right? And unfortunately, this is a topic that I'm not so familiar with. So please forgive me if I can't explain it in very detail. Okay, so anyway, because it's binomial expansion, and I believe that the formulas are given, right, for binomial expansion, binomial series. And wait, let me check. I think I have your formula list. Yep. Okay, so the binomial formula, yeah, it's here. It's a very long formula, so I don't think I will copy it there. Just you know that which formula I'm talking about is enough. Okay, I'm talking about this formula. Binomial expansion. Okay. This formula. Okay, so I will just use it there. And because it asks us to find the coefficient, so we actually don't have to expand the whole thing out. Just for x6, okay, to x to the 6 and x to the third power. Okay, so how do you get x to the 6? It's actually very simple. It's 6c2 times, because you see the first thing that you have here, 2x squared to the 4th power, then a over x to the 2nd power. Okay, so this is how you get your x. Then how about the coefficient of x cubed? And of course later we will compute this later when we compare both of them together. Okay, so it will be 6c3 times 2x squared to the 3rd power and a over x to the 3rd power. Okay, so when we compare the coefficient of x6 and x cubed, we'll have 6c2. Okay, well, how much is 6c2? Let me use a calculator here. It's 6c2 is 15. Okay, 15 times 2 to the 4th power, and then you have x squared is equals to, because we are comparing the coefficient, right? Then 6c3 is 20. 20 times 2 cubed, then a cubed. Let me get rid of this calculator. I don't think we need it. Alright, so we just go ahead and find the value of a. Okay, so divide both sides by a square. 15 times 2 to the 4th power is 16. Actually, no, we don't explain it here. 2 to the 4th power, this and that will cancel. 20 times 2 to the 3rd power, this and that, this will just left a to the 1st power. So just rearrange it. Your a is 15 to the 4th power over 20 to the 3rd power. Okay, this and that power will reduce, and this is actually 3 over 4. So it's 3 over 4 times 2, which is 6 over 4, which is 3 over 2. And that's it. It asks us to find the value of constant a, right? So yeah, that's it. Then next, find the coefficient of x to the 6 and the expansion of that. Okay, 1 mark, so should be very direct. Actually from here you can see already let me explain it like maybe, okay, so the highest power in the first bracket is x cubed, right? Then the highest power in the second bracket is 2 times 6, which is x to the 12. So when you multiply them together, it's like no matter which one you multiply to, it's impossible for you to get x to the 6 for this expansion, right? So the coefficient of x to the 6 will just be 0. Yeah, that's it. Okay. Okay, number 6. The equation of the curve. Okay, so this is actually a semicircle curve. If you go and graph it out, and find the coordinates of the point on the curve which have a gradient of 4 over 3. So again, it's a differentiation, right? It's talking about derivatives, because you know that first derivative is actually your gradient function. Okay, so just go ahead and differentiate this. Y equals to 2 plus square root of 25 minus x squared, and dy dx will just be, you differentiate a constant, it becomes a 0, you differentiate a square root, it becomes 1 over 2, 25 minus x squared, then remember the chain rule, inside is negative 2x to the first power. Okay, and now your 2 and 2 can cancel. Let me write one more step, negative x over 25 minus x squared. Now the question tells you that the gradient is 4 over 3. So you just go ahead and let this dy dx be 4 over 3. Find the value of x, sub it back to the equation to get your y, and you can find the coordinates. Let me just do it like, just put it here. Negative x over 25 minus x squared equals to 4 over 3. Rearrange it, equals to 4 over 3 times with the square root of, no, I think I better square both sides first, okay? Because now I still can square both sides. It's easier for me to square both sides now. So it will be x squared equals to 16 over 9 times 25 minus x squared. This square root and square will cancel off. And it's a quadratic equation. Just go ahead and do x squared equals to 16 divided by 9. I think I will just put 9 over 16 times 25 is 400. Okay, 400 minus 16x squared. Bring it over, you see, it's very nice. 25x squared is 400. 400 divided by 25 is 16. Right? 16. Then your x will be plus minus 4. And do we need to check any condition? Does it tell you the domain of x? Sometimes you have to check, especially when it has a square root. Okay, so if you sub 4 inside, okay, because you know that your square root can't take negative values, which means your x squared must be always smaller than 25. This is a condition for it to have real solution. And in this case, because it is a 4 square is 16, right? 16 is smaller than, sorry, 25 should be greater than x squared, okay? So 25 is greater than 16, so no problem for 4 squared. Same goes with negative 4 because it is still a 16. So yeah, the question is, the answer is okay, very nice. Just go ahead and, so we will have two coordinates. Yeah, find the coordinates. So just sub it back when your x equals to 4, y equals to 2 plus 25 minus 4 squared, which is 2 plus 25 minus 16, which is 2 plus 9, which is 2 plus 3, which is 5. And when x equals to negative 4, y equals to 2 plus 25 minus 4 squared. So you know that this is actually the same, right? It's still 16, so it's equal to 5. Therefore, the coordinates is 4, 5, and negative 4, 5. This is when the equation, this is when the curve has a gradient of 4 over 3. Okay, next. Oh, triangle identity question. Okay, I like this question because it gives you a lot of information on left hand side, right? So definitely we'll start from left hand side. Okay? And yeah, I think it's very straightforward because you have all the sign and you know that somehow you will get the cos better, okay? You by identity, and you have a sine square I think you will have a sine square on top, a cos square at the bottom, and you can combine together, become a becomes a tangent square. Okay, let me start from the left hand side, equals to, I just directly combine, I'll just get one step here, 1 plus sine theta minus sine theta, 1 minus sine theta. And because they have a common denominator now, I'll just put them together. Okay, 1 minus sine theta, 1 plus sine theta. Then just go ahead and expand this. Be very careful of the positive and negative. Okay, so it will be sine theta plus sine square theta minus sine theta. Minus becomes a plus sine square theta. Did I copy anything wrongly? No. Alright, good. And for the denominator, you have something very nice, which is the difference of square. It's actually a plus b. Okay, a minus b, a plus b, and it is a square minus b square. Okay, so it will just be a square minus b square. See, I told you you'll somehow get an identity and you can make it into cos. And on top, you can just cancel this, cancel that. It will be 2 sine square theta over cos square theta by Pythagorean, or you call it basic identity. Okay, identity. It will be 2 tangent square theta. End of proof. QD. Then next, okay, hence solve the equation of that one. So obviously, because you proved the identity and part A, so you'll make use of what you have here, which is 2 tangent square theta. 2 tangent square theta. Wait, before that, let me check. Is it the same? Is there any trap here? Okay, it's exactly the same. So just 2 tangent square theta equals to 8. So move the 2 over, it will be 4. Then square root both sides. Okay, can you square root both sides? Let's check. On right hand side is a positive 4, so it will not get an I. So okay. On left hand side, tangent square is a square, so it will always be positive. Therefore, you can square root it. Okay, but I also write it wrongly lah. So tangent theta equals to plus minus 2. Plus minus 2. Okay, then we have to do it separately lah. But before that, just now I forgot to mention, because it told you that the range is in between 0 and 180, so you don't have to consider the whole cycle, or you don't have to go around and get until I don't know how many cycles. So because of that, and you know that you need to consider both positive and negative, and luckily you only have to consider first quadrant and second quadrant by what? By the old science teacher crazy. When it is positive, it is quadrant 1. It can't be quadrant 3 because it's out of the range. When it's negative, you know it is from quadrant 2. Can't be quadrant 4 because also out of the range. Then you just go ahead and do your theta, okay, is arctangent of 2 and also arctan. Let me write it like this. Arctan, because some people don't like to write it in like exponent form. Even though we know that is the meaning of the negative 1 is an inverse. But then I just write like this for the sake of writing it. So okay, I write it later. So when it is like that and you want to give your answer in terms of degree. Okay, so let me use the calculator again. Arctangent of 2. 63.4349. Okay, goes to 63.4349. This is the answer in quadrant 1. And arctangent of negative 2, you know that it is just 180. Okay, let me write down. 180 minus 63.4349. Okay, I'll just cross this. Degrees. Then I need a calculator. So sorry about that. 180 minus 63.4349 is 116. Okay, 63. Remember the unit is degree, and 116.5651 degrees. Because I always like accidentally press it, so I don't like to do that. And that's it. For do we need to write it here? For theta in between 0, not include 0, not include 0, and 180 degrees. Okay, so this is how you would do that. But if you want to write it, you want to be more detailed, you can actually draw the reference angle. Okay, so let me do it for you. Okay, we'll let tangent alpha be 2, which means it is like this, your reference angle, this is your alpha. So alpha will be arctan of 2, which is, just now we already pressed the calculator, is 63.4349, and this is your reference angle. So in quadrant 1, your theta will be equal to alpha, which is 63.4349 degrees. In quadrant 2, your theta will be 180 degrees minus alpha, which is 116.5651 degrees. Okay. If you want to be more detailed, you can write your answer like this. No harm. Okay, next. A geometric progression as the first term a, common ratio r, blah blah, sum to infinity s. Then second geometric progression has the first term a, common ratio big R, and sum to infinity of 2s. And show that r equals to 2 big R minus 1. Okay, so just remember your sum to infinity formula. But before that, something that you need to check is the absolute value of r and big R, are they smaller than 1? Does the question mention about it? Because you know what, if your R, for a geometric progression, if your absolute value of R is greater than 1, the series means when you add them together out, your sum to infinity will actually diverge. So I'm not sure whether they miss out in the question or they do an assumption that your R is smaller than, your absolute value of R is smaller than 1. So let me just write it here. Assuming that absolute value of R is smaller than 1 and absolute value of big R is smaller than 1, so that the sum will converge. If not, it will diverge. You will never be able to compare. Okay? So assuming that both of them is smaller than 1, so that the series will converge. The sum of the first series, it told you is S, right? Sum to infinity is equals to A over 1 minus R. This from the formula list, right? And I think it is given. I guess so. Oops, sorry. Where is the... Did they give you the geometric progression? Yep, it is here. This one, sum to infinity. Okay, so come back here. This is your equation 1. So equation 2, it told you that 2s is equals to a over 1 minus r, right? And I will just write one more step like this, 2 1 minus r, so that I can directly sub equation 1 into equation 2, or you can say compare or whatever that you like. A over 1 minus r is equals to 1 a over 2 1 minus big R. Wait, okay, I don't want to I don't want to A because you don't see any A here, isn't it? Just go ahead and cancel off. So 2 minus 2 big R equals to 1 minus small r, right? And I want to write in terms of small r, shift over, r equals to 2r, then it is 1 minus 2, which is minus 1. And is it what we want? Yep, it is. So shown. Okay. Next, it is now given that the third term of the first progression is equals to the second term of the second progression. Express S in terms of A. Okay. So wait. Okay. So for the first geometric progression, okay, your t to the third, the t3 will be a r n minus 1, which is a r squared. I think this is also given in the formula list, and I hope you can remember this. And for the second geometric progression, your second term is a r n minus 1, which is a r to the first power. Then we want to express s, so means I think we need this. We need s. But do you have anything? Yeah. Okay. So from A we already proved that. Just write this. From A we know that r equals to 2 big R minus 1. Right? So we just go ahead and sub into one of them so that we can compare. And in this case, I think oh wait, this big R, sorry, big R, A times big R. And in this case, I think I will just do a few more works before I sub into it, because I don't want to sub into a square, because if you sub into a square, you tend to make mistake. Alright, so I will write big R in terms of small r, which is actually half of small r plus 1. Right? So I will sub this into, I will sub it into here. And you know that your T3 for the first progression is equals to your T2 of the second progression. Therefore, A half R plus 1 sorry, not like this. Is here I meant to sub here because I don't want to sub into the square, because if I sub into a square I tend to make mistake. I always forgot the term in the middle, always forgot the 2AB. That's why I don't want to do that. Okay, so now AR square equals to A times half. You see, now I don't have to worry about my R or R square or whatever. And A can cancel, equals to 2 R plus 1. Oh, it's a quadratic. 2R square plus R, minus R minus 1 is equals to 0. Right? So it should be 2R and a R, and you should have 1 and negative 1, right? 1 and negative 1. Okay, it should be a plus here minus here. Okay, equals to 0. You can just go ahead and do a tic-tac-toe method, or you just use a calculator. I think you can just use mod 5, 3. Okay, 2, negative 1. Yeah, it is. Yep. So your R equals to negative half and R equals to 1. Oh, so here's the thing. Because in the previous question, it told you that the sum to infinity is something that finite, right? It's actually converged, right? So absolute value of R must be smaller than 1, so that what you did in part A makes sense. Therefore, this will be rejected. Okay, it's rejected. So R equals to negative half. And what about your big R? Okay, your big R will just be somewhere negative half plus 1, which is actually 1 over 4. Oops. Actually we don't actually need a big R. We already have a small r, and because we want S in terms of A, so just go ahead and sub it back in terms of for our S formula. Okay, so S formula was just now with small r is this one. S equals to A over 1 minus R. S equals to A over 1 minus R. Now you know that your R is negative half. So S equals to A over 1 minus half. So these are 2 over 3. Flip it. S equals to, my brain works too fast. Okay, this is 3 over 2. You flip it, becomes 2 over 3. Okay. And that's it. S in terms of A, right? Okay, so that's for question 8, and I think I will end here for part 1. See you guys in the next part of the video, alright?